And here, because we are having 4 groups, t-test is not going to help us. So we have to find another way. The another way is known as the Anova. Anova helps us to find the significant difference between the means, that is H naught. For example, if I am taking H naught as null hypothesis, mu1 equal to mu2 equal to mu3 equal to mu4. Here mu1 is nothing but production of the crop for P1 and P2 for mu2, and for P3 we are keeping mu3, and for P4 we are keeping mu4. So this is how the this is how the Anova null hypothesis is framed. So for the alternative hypothesis for Anova will be H1 will be mu1 not equal to mu2, not equal to mu3, not equal to mu4. Okay, that is the alternative hypothesis for Anova. So we are going to see what are the uses of Anova. Some of the examples of Anova I have given in another class, another video lesson, you can check. And now we are going to see what are the uses of Anova. Anova is used, the main reason is you will have a doubt whether we can use t-test. That is t-test for P1 to P2, another t-test for P2, P3, another t-test for P3, P4, another t-test for P4, P1. So if you do such combinations of t-test, there will be alpha inflation. Because for every t-test, we are, for example, we are fixing 95% level of significance, then 5% it is a doubt. Okay, so if you conduct t-test for P1, P2, there is a doubt 5%. For P2, P3 again 5% there is a doubt, and P3, P4 doubt, P5% doubt. So by this way, alpha inflation takes place. So t-test may not be that much helpful in this case, and it is time consuming, and cost is also more. So unnecessarily we are doing t-test, and moreover the alpha level has to be fixed very low according to the formula. That is one formula for that. 1 minus alpha the whole power n means how many groups are there? If 3 groups, then that much power. So it will be what to say, power of the test, there will be a problem. Therefore we are going to use Anova, and Anova is very useful, right? And how it is, we will be seeing the uses of Anova. So it is better than using the t-test. By this time you understood, I think, right? What is Anova? Anova is nothing but analysis of variance. Okay, if you means actually we are finding the variance between these 4 groups. Okay, here we took 4 groups now, variance between these 4 groups. So analysis of variance, that short we are writing as Anova. So what are the uses? The first use is to test the homogeneity of several means. Suppose you are taking k groups, right? Previously here the example was 4 groups. Now, if you are taking k groups and you are finding the mean of each and every group, that is a population mean. So k groups means that will be k population, and its mean you can denote it by mu1, mu2, mu3, and so on to mu k. So what will be our H naught? H naught will be mu1 equal to mu2 equal to and so on to equal to mu k. That will be our H naught. So it is checking the homogeneity of this means, several means. If H naught is rejected, suppose you are statistically the Anova whatever you calculate is greater than the F table, then you reject the null hypothesis. That is, if H naught is rejected, then we can say that there is a significant difference between these k groups, or there is a significant effect of these k independent variables. So this is what you conclude from the Anova. There is significant difference between these 2 these groups, right? The first use we are going to see. What is the first use? Is the homogeneity of, that is what I explained you, homogeneity of several means, right? That is K groups. Okay, that is H naught, mu1 equal to mu2, the null hypothesis, how you can frame mu1 equal to mu2 equal to mu3 and so on to mu k, right? That is, this is the alternative hypothesis will be H1 mu1 not equal to mu2 not equal to mu3 not equal to and so on to not equal to mu k. That is, there is significant difference between these k independent variables. Now the question, you will have the doubt of independent and dependent variables, right? Because I am introducing the new term, independent variable. In the field example, what I gave you is the growth of the crop is dependent upon the water you are using, fertilizer, new old fertilizer, new fertilizer, and also compost. So all this has effect on the growth of the crop, right? And these are said to be water, water, new fertilizer, old fertilizer, and also compost. They are said to be independent variables. The growth of the production of the crop is known as the dependent variable. That depends upon the fertilizer which is used or whatever you are using. So that is known as the dependent variable. So these are whether independent variable has an effect on a dependent variable. That is what you are finding, right? If H naught is rejected, what you do means we are going to accept H1, right? The alternative hypothesis. There is significant difference between these K groups. Okay. So next one is to test the relationship between two variables. Means you are telling there is significant difference and between variables, for example, mu1, mu2, mu3. Okay, you are accepting there is significant difference, but to what extent the relationship is, to what extent we have seen in the regression, right? Coefficient of correlation. Okay, to what extent the relationship is there? That what extent means how the independent variable is affecting the dependent variable, to what extent it is affecting, then you are that relationship is also you can find using this ANOVA, right? That is what for example we are telling that independent variable. Here I am explaining what is independent variable. Our water is the independent variable. Water, new fertilizer, old fertilizer, right? Independent variable. Old fertilizer also independent variable. Compost is also independent variable. So these are all the independent variables, right? And dependent variable is the growth of the crop, right? How the crop P1 grows. That depends upon the water you are using, right? That is the dependent variable. Here also P2, the growth of this crop P2 is also dependent. Growth of the crop P3 is dependent. Growth of the crop P4 is dependent. So there are 4 independent variable and 4 dependent variable in this example, right? How this independent variable, to what extent it is affecting the dependent variable, and this relationship is established using the ANOVA. That is to this test provides evidence that dependent variable Yij and the independent variable Xij are related in their movements, right? If Xij, Yij do not relate with Xij, then we accept, that is H naught. We accept the null hypothesis H naught, which is the null hypothesis for testing the absence of relationship, right? There is no relationship, we say. So to test the relationship between two variables, that is the second user of ANOVA. And the third use is nothing but test of linearity of regression, right? Test for linearity of regression. Means you are having the relationship, no, using the formula, that regression formula, mu I equal to alpha plus beta xy. This relationship you are finding using the ANOVA, right? Linearity of regression means if x varies, x has to what extent impact on y2. Okay, x2 is what? Independent variable, y2 is dependent variable, x2 is what? Independent variable, y2 is the dependent variable, x2 has impact on y2. Okay, to what extent it is having the impact? That is the relationship between x2 and y2. Means how when x2 varies, y2 also varies. Means this relationship you are trying to establish using this ANOVA. And this is nothing but, suppose you are having the straight line now, y equal to mx plus c, the straight line equation. Means if there is a change in x, then y also changes. So this relationship you are trying to find. Linearity means the straight line. This is the example of linearity of regression. Okay, x and y, if you take it, can plot on the graph like this. So this linear relationship we are trying to establish. That is yij equal to mu1 plus something like cij into k. This is equal to y equal to mx plus c. Same way. Okay, these are the things we can do using the ANOVA. The fourth one we'll see in the next class.